So let's say the point 12.5 lies on the terminal side of an angle in standard position. What would that angle look like? Well, since we do know the point, we can plot it. We'll go over 12 and up 5, and it gives us a spot right here. So the angle in standard position would have its initial side on the positive x-axis, and its terminal side, it says we'll go through that point. And we're looking at this angle, theta. Now the question is, what are the 6 trig values of that angle? And the best way to do this is, since we have it graphed, we can look at this as a triangle. And that's what we want to do. We'll turn this into a right triangle here. Since we know this point is the point 12.5, we went over 12 and up 5. Doing a little bit of Pythagorean theorem, we can say 12 squared plus 5 squared is equal to whatever c is squared, if we call this c. You can work that out and you'll find that this is going to be 13. And now, since I know all 3 sides of my right triangle, since this is a right triangle, finding the 6 trig values is not going to be difficult. All we need to do is remember SOHCAHTOA. Sine is opposite over hypotenuse. Since here is where our angle theta is, the opposite side is 5, and the hypotenuse is 13. The cosine is adjacent over hypotenuse, so that's 12 over 13. And tangent is opposite over adjacent, or 5 over 12. To find the reciprocal trig values, all we have to do is take the reciprocals. The reciprocal of sine is cosecant. So since sine was 5/13, cosecant is going to be 13/5. Since cosine was 12/13, secant is 13/12. And since tangent was 5/12, cotangent is going to be 12/5. So now what if we generalize this idea? What if we're talking about any point that lies on the terminal side of an angle alpha in standard position? Well, we can, just like before, draw the triangle in there. And we can create this right triangle. And we know a couple of the lengths. I know that since we're going through the point xy, we had to go over x units and then up y units. And if I were to call the hypotenuse, say, r, we could do Pythagorean theorem and say that x squared plus y squared is equal to r squared. And to find out what r is, we would just take the square root of both sides, so that r is the square root of x squared plus y squared. And now that I know all the sides of my right triangle, referencing angle alpha here, the sine of alpha is going to be opposite over hypotenuse, or y over r. The cosine would be adjacent over hypotenuse, and the tangent would be opposite over adjacent. Of course, the reciprocal functions of cosecant, secant, and cotangent are going to be the reciprocals of those 3 fractions. Now, what happens when that terminal side isn't in the first quadrant anymore? So now we're talking about the point -3, 4 being on the terminal side of position angle theta. So if I draw theta in, the initial side is going to be positive x-axis, and the terminal side is going to contain the point -3 and +4, so right about here. When I draw the terminal side, the angle theta that we're looking at is right here. How we've been going about this is, though, to find a right triangle. And the triangle that we want to use is the triangle that's made with the nearest x-axis. Then my base is -3 and my height is 4. And of course, the angle theta that we're looking at is on the outside of this triangle. However, we can use its reference angle here, theta prime, in order to identify those sines, cosines, and tangents of theta, because theta and its reference angle are going to act the same. Well, now we have to identify what this r is, and we go back to r squared is equal to x squared plus y squared And even though you're in Algebra 2, you still make this dumb mistake sometimes, and you say that negative 3 squared is negative 9, but it's not. It's a positive number. It's 9 plus 16, so r squared is 25. And when I take the square root of that, r is going to equal 5. The thing about this r, this hypotenuse, it will always be positive. Okay. Now that I have my triangle completely filled in, we can use that to identify all 6 of the trig values. So if I want to find the sine of theta, it's going to be the same as the sine of its reference angle. So we go opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. To find the reciprocal trig values, we just take the reciprocals. The reciprocal of sine is cosecant, so cosecant of theta is 5/4. The reciprocal of cosine is secant, so that'd be 5 over negative 3. And the reciprocal of tangent is cotangent, which is negative 3/4. Let's see what it looks like when our terminal side now is in the third quadrant. Drawing our theta in standard position. Initial side is positive x-axis. Terminal side is going to be negative 9, negative 1, right about here. Making this our theta. When we're trying to identify all of the trig values, we don't necessarily look to theta, we look to its reference angle. Just inside of here, that's where theta prime would be. Remember this right triangle that we drew? We went back 9 and down 1 to get to this point. And now we have to find out what r is. Use a little Pythagorean theorem. R squared is negative 9 squared plus negative 1 squared. So r squared is 81 plus 1, or 82. And r would be the square root of that, 82. Try and simplify it by factoring 82. I know that it's 2 times 41. Both 2 and 41 are prime. Neither of them are perfect squares. So r is going to be the square root of 82. Now our right triangle is completely filled in. We go over to identify the 6 trig values of theta. Right? Since it's where theta is, its opposite side is negative 1. And the hypotenuse, square root of 82. Of course, we should rewrite this as negative square root of 82 over 82. The cosine is going to be negative 9 over 82, or square root of 82, which makes negative 9 root 82 over 82. And tangent is opposite over adjacent, or 1/9. Now we just take the reciprocals to find cosecant. And I'm not actually going to take the reciprocal of this fraction. I'm going to instead take the reciprocal of this one, because when I do, I'll get negative square root of 82, and there's no radicals in the denominator or anything like that. So same thing with cosine. I'm going to look back to my unsimplified version, take the reciprocal of that, and get negative square root of 82 over 9. And for tangent, I will look at the simplified version and just take the reciprocal, and that gives me cotangent of 9. Well, we've done all of the other quadrants, so we might as well see what it looks like in the fourth quadrant as well. If we're looking at 6, negative 10, our initial side is positive x-axis. And I'm going to go over 6 and down 10 to get a point on my terminal side. This is theta on the outside. I want to look at the reference angle of theta prime on the inside. And I draw my right triangle with the positive x-axis. My point was 6, negative 10. That meant I went 6 in the x direction and negative 10 in the y direction. And now we have to identify what the hypotenuse is. Now, don't think that just because you see a 6 and a 10 that this is going to be the old 6, 8, 10. No, take a second and do the Pythagorean theorem. I know that r squared is x squared plus y squared, negative 100, negative 10 squared. So r squared is going to be 36 plus 100, or 136, making r equal to the square root of 136. We should see if we can simplify this root. It looks like 4 is going to be a factor. When I take 136 divided by 4, I do get 34. I know that 34 is going to be 2 times 17, and neither of those are perfect squares. So let me move this down here. When I simplify that root, I'm going to see that I get 2 from the square root of 4. And 2 times 17 is back to being 34. Right? And that's what my radius is, or my hypotenuse here, 2 root 34. Now it's time to go over and identify our 6 trig values. Remember, identify your reference angle here. And to find the sine, we're going to do opposite over hypotenuse. So the opposite was negative 10, and the hypotenuse was 2 square root of 34. Of course, the 2 and the 10, I'll leave 5. And simplifying that, I'll get negative 5 square root of 34 over 34. For the cosine, that's adjacent over hypotenuse. The 2 and the 6 cancel. And this will leave me with 3 root 34 over 34. And the tangent is opposite over adjacent. We can simplify that 2 into negative 5 thirds. To find the last 3, we just take the reciprocal of the first 3. And so the reciprocal of going back to the unsimplified version, taking the reciprocal of that, I will get negative root 34 over 5. For secant, I'll take the reciprocal of 3 over root 34, which is root 34 over 3. And for cotangent, I'll look to the simplified version of tangent and take the reciprocal, get negative 3/5.